All right, so we are going to go over a conversion or using factor label of the metric system. So just before we even start the problem, I just want to write out our prefixes again. So we have K, which is kilo, H, which is hecto, D, which is deca, and remember this can also be written as DA, and then we have B, which is your base. And just remember base is going to be your plain unit, so that would be just your meter, liter, gram, seconds. So no prefixes in front of those. Then we have lowercase d, which is going to be your deci. And then we have c, which is centi, and m is milli. And as you go from left to right, they get 10 times smaller. Okay, so we're going to practice writing one equality first, and then we'll do a dimensional analysis problem. So let's just go from let's say we have 1 second, and we're trying to figure out, well, how many milliseconds are in a second? So if we just have a second, it means that we're starting at our base unit. And if we're trying to go to milliseconds, well, then we see we have the prefix milli. So we're going to find the lowercase m to match, which is the milli to match. So if we look, we want to figure out, well, how many times does it take us to hopscotch from the B to the M? So our starting point is on the B, and we're trying to get to the M. So we're going to jump, and we go 1, 2, 3. So we hopscotch 3 times. So that tells us we have 10 times 10 times 10. So it's 10 times each time you move. We did it 3 times. So it ended up being 1,000. So that's how you get to the equalities. Now we're going to do an actual factor labor problem or a dimensional analysis problem. So I'm going to go through and we're going to say we have, let's say we have 8,210 centimeters. And I want to figure out how many kilometers do we have. So that's what we're trying to solve for. So we first want to write our equalities out. So that's always our first step. So we want to go through and figure out, well, what are the equalities we're going to use? So we have the K, H, D, B, D, C, M. Remember our base unit, that's always going to be our stopping block. So no matter what, we always have to stop at our base unit. So we have to figure out, well, where are we starting? So we want to look at our given. So we're starting at centimeters. So that has to be our starting point. So we know that we have to include centimeters in our equality. And then let's see where we're ending at. So we look, we're ending at kilometers. Okay, that means that the K has to be somewhere in there. Well, we cannot go straight from C to K, so we have to take a pit stop. So we're first going to go C, and then we have to get to B. So we have to figure out, well, how many base units are in how many centimeters? So remember, we read it left to right. Well, we run into our base unit first. Okay, so if we read KHDB, we read our B first. So we know that 1 meter, and we're talking about meters in this problem, that'll be our base unit, is equal to, because remember we always have to stop at our base unit. Remember we're going from to centimeters. So we have to count. All right, hopscotch over 1, 2. So we only have to jump over 2 times, which remember would be 10 times 10, which gives us 100. So we have one of our equalities, but we said we had to include K, B, and C all in our thing. All right, so we got our C to our B. All right, but we also needed our K to our B, because remember, we always have to stop at B. Our base unit's our stopping port. So now we have to write our second equality. So now I read K versus B. Okay, well, when I read that, I read K first. We know that 1 kilometer, because remember the K stands for kilo, and we're talking about meters, equals, and then we look, and it's 1, 2, 3 base units over, or 3 jumps over to get to the base unit. So that would be 10 times 10 3 times, which gives us 8,000. Now we have our equalities made, and so now we're going to actually start the problem. So we're going to start our problem, and we always start with our given. So I'm going to take our 8,210 centimeters. I'm going to put that over 1 just to turn that into a fraction. That 1 you do not have to put. Again, I'm just putting it to keep things neat. Now I'm going to set up my fractions. And remember, the whole goal of fractions is to get units to cancel out. So we want to look at the unit that we're currently in, which is centimeters. We have our equality A and we have our equality B. So we have to figure out which we're going to use. Well, which one has centimeters? Because that's the unit we're trying to cancel out right here. All right, if we look, that's A right there. We have our centimeters. So that means that we are using equality A first. So we're going to put our units to cancel out. Remember, if we have centimeters in numerator, we need centimeters as a denominator. So we'd have 100 centimeters down here, which means that the 1 meter goes on top because you can't break up this equality. So now let's check our units. Centimeters are gone. We're left with meters. Okay, but if we look at our problem up here, it's asking for kilometers. So we're not finished yet. We have to keep going. We have to get that meter into kilometer. But look, we already wrote that equality. Okay, so right now we have our meter and kilometer. We can use this equality. So I'm going to put the part with the meter because we have numerator meter. I need denominator meter. So I want to put the 1,000 on the bottom and the 1 kilometer goes on the top. Okay, so now our meters cancel out and we're left with our kilometer. That's the only unit that we have left right now is our kilometer. Everything else we have a numerator and denominator of. And now we can calculate it out. So you multiply everything on top. So you do 8,210 times 1, which just gives you 8,210. And then you divide that by your denominator. So you're going to do 100 times 8,000. So you'd end up getting 100,000. And you end up then dividing. I'll just show you what you're going to write down. So it ends up like this. Okay, the only unit left is that kilometer. And you divide that by 100,000. There's no units left in the denominator, so those are all canceled out. And so we end up just then dividing these and you calculate them out. And so when you calculate those out, we want to look at our sig figs. Okay, so this has 3 sig figs. So remember that 0 doesn't count. Okay, we never count that 0 because it does not have a decimal and it is a trailing 0. And so we just put 0.0821. So do not put a 0 at the end, and it'd be kilometers. And that's our final answer. We have 3 sig figs, 3 sig figs, so we are good.